Hello friends, welcome to my YouTube channel Make Maharashtra, which gives you educational videos. We have solved one numerical on sliding contact bearing. Second numerical I'll solve for you this. See here, number of time I am solving the numerical, it doesn't mean that you are practicing it. By listening it won't practice from your side. So for that you need to practice. You take a pen, paper, calci and do the calculation from your side. Clear? So try to solve this numerical with me. Now I'll read the numerical. The following data is given for 360 hydrodynamic bearing. The journal diameter, that is shaft diameter, is given. The 50 upper and lower limit they have given. So this is small d, and bearing diameter, this is capital D. In that they have mentioned 50 upper and lower limit they have mentioned. The bearing length small l is 50 mm. The journal speed they have mentioned. Generally we have taken the journal speed in RPS. So 1500 divided by 60 RPS. So radial load, of course it is acting toward downward, that is 5 kilonewton. The bearing is machined on the lathe from the bronze casting, while the steel journal is hardened and ground. The surface roughness is C by A. They have given. The value of the turning and grinding are 3.2 and 0.8. So these are the values they have given for turning and grinding in microns. For thick film hydrodynamic lubrication, the minimum film thickness should be 6 times the sum of the surface roughness value. Surface roughness value is, they have given 3.2 and 0.8 and 6 times of it. Just read carefully for writing the given data. For the journal and bearing, determine the quality and quantity of the lubricant. Quality means, first of all you must find out the viscosity, and quantity is nothing but you must find out the flow rate Q. So clear problem? So read the problem carefully and write down the given data. As per the radial clearance I need to go. Why? Because first of all they have given the diameters of the bearing and diameter of journal. So capital D is for bearing, small d is for journal. So you can see I have mentioned here the upper limit, I took the average. Now see, upper limit 50 plus 0.03, you can see this is the bearing, 0.03 I have mentioned here, plus 0, that is lower limit, divided by 2. This answer will be this much, 50 point something. Now average diameter of the journal, that is shaft, 50 plus, you can see the upper limit is 0.008. So I put here and I'll get 49 point something. So this is very important, the diameter conversion, because they have given, so that the clearance is nothing but capital R minus small r, which we have seen. So R is not given, so we are having the right now diameter. You can make the diameter radius of this, or you can make d minus d divided by 2. It will gives you the answer, that it will be the radial clearance 0.059 mm. This would be the first step. Clear? Second, to find out the minimum oil film thickness, because the term they have given, what see, the film thickness hydrodynamic lubrication, the minimum film thickness should 6 times of the surface roughness value. These are the two surface roughness value, 3.2 and 0.8. So 6 times surface roughness value, that's why I have added here HO is equal to 6, 3.2 plus 0.8, it is in a micron. So micron answer will be 24. It will be converted into mm, multiply by 10 raised to minus 3 mm. It will gives you. We know HO by C, oil film thickness, because that parameter indicate in the chart. So C is given and HO also we have calculated. So here we are going to calculate HO by C term. Now you can get HO by C, 24 into 10 raised to minus 3 divided by C clearance. It will gives you 0.4, correct? 0.4. Go to the chart of the Raymondis and Boyd method. First of all I must know L by D ratio. So I will have to check L by D ratio. It is 50, diameter is 50. L by D ratio is how much? 1. So for 1 diameter, and the HO by C value we have calculated that 0.4, correct? 0.4. So I'll check for 0.4. See the chart carefully. Now L by D ratio is 1. Am I correct? HO by C is this column, and 0.4 we got. So this will be the 0.4. I got the chart row, which is the required for solving the numerical. So this row you as it is copy. So I'll write here. Did you get? Okay, see, I copied this row. L by D how much, HO by C how much, yes, bearing characteristic number, then control flow variable, pressure and flow rate. Correct? So that row I copied. So this selection is very important. In previous numerical, we have selected this from the bearing characteristic number. But right now the given data is related to oil film thickness. So that's why according to oil film thickness, I have chosen the row. Is that clear? So I'll use one by one what they are asking. So they are interested in quality of the lubricating, that is viscosity. So viscosity in which equation, parameter equation? Of course, it is situated with respect to bearing characteristics, that is Sommerfeld number. Here mu is there. Correct? So I use S is equal to R by C bracket square into mu by NS by P. Correct? So mu is not known. So but I can calculate projected area, that is P is equal to W divided by L into D. W radial load known, L into D known. So it will gives you 2 Newton per mm square. So I can put this value. S value, that will be the Sommerfeld number. You can check from the diagram. For 0.4, S value is 0.121. So I took here 0.121 is equal to R by C bracket square into RPM. I will have to take in RPS, revolution per second, into projected area. This will be the 2. So from this I'll get the viscosity. It is in Newton second per mm square. So I can directly, I know that if viscosity is in 10 raised to minus 9 terms, I can convert, say that will be the centipoise. So I told you the conversion. So therefore it will be the viscosity is 54.83 centipoise. Is that clear? So this will be the step number 5. Quantity. Now in case of quantity is nothing but Q. How much flow rate? It is in a liter per minute. So that we need to calculate. We know Q by RCNS. Q is situated here. So that's why Q by RCNS L is equal to 4.33. So I will have to mention here 4.33, and I put the values, all the values which we have calculated. Here do remember that here value should be in RPS. Now Q value is mm cube per second. So I told you how that conversion in liter per minute. By same method I'll convert this. Well, I'll get 0.4831 liter per minute. So that kind of the conversion will get, and as per their requirement we have calculated 2 data, that is one is the quality and second one is a quantity. Clear friends? So such kind of example will be asked in the exam for 6 marks. You have to do the practice from your side. Now this will be your homework. Just take it screenshot and make the homework stepwise and submit it to me. In the assignment also I'll add this numerical, so that try to find out and solve. Clear? Okay. Thank you.